Okay. Hello, everyone. Thank you so much for coming today. As you may already know, we have an amazing guest speaker lined up for React Native today. And Ram is going to be talking about some inspiration for why React Native was created, as well as some background details. Before that, I have a couple announcements to make, just some casual things. If you are still following along with the membership portal for ACM and you want to get some points, I'm going to put in the code for today in the chat. And also, as always, feedback means a lot to us. So if you have anything you want to share about how you felt about this workshop, it will help us a lot in terms of improving these workshops in the future if we have any guest speakers in the future. So I'll put a link for that as well. Last thing, if you are interested still in showcasing your app next week in the project showcase, we're going to be releasing our dev post submission this Friday. So be on the lookout for that. I'll make a more formal announcement related to that this Friday. So without further ado, I'll pass it off to Ram for his presentation today.
Hey, thanks, Eugene. And the app showcase sounds interesting. Just for your context, we did a similar workshop with the University of Puerto Rico, and we actually had people from them come talk to us about the amazing apps that they had created, and we were actually pretty impressed with the kind of apps that they had built. If you think your group has some interesting apps in React Native, you should reach out to Christine. She would be more than happy to come take a look at the apps and give you folks feedback. So that's something we could do. We have done this in the past where people from Facebook have come, looked at your app, and like it was more like an informal 1-hour conversation where we chat about the different apps, and it was more like, hey, this is what we did, this is the technology we use and stuff like that. Anyway, with that out of the way, let me actually go ahead and start my presentation, which is why I'm here. So hey everyone, my name is Ram. My actual name is Parshuram, which is kind of long, so you should just call me Ram. That's much easier. I'm an engineering manager in Facebook. I primarily work on Oculus, the virtual reality headset, and I primarily build user interfaces. A lot of the work that I do is related to building user interfaces and immersive user interfaces. But I've not always been at Oculus. Before this, I was on the React Native team, the team that builds the framework that you folks are using. And as you know, React Native is a way to build mobile applications for iOS and Android with JavaScript. JavaScript is actually a super simple language. It's very easy to get started, and that's why we chose JavaScript as our language of choice when we started building React Native. I've been working on React Native for a while, but before that, I was at Microsoft, the big Windows company. And at Microsoft, I used to be a part of what is called Apache Cordova or PhoneGap. A lot of people here may not have heard of it, but Apache PhoneGap or Cordova was the thing that came when a couple of years after the iPhone was released and people could build apps for iPhone. And it was also a way to use JavaScript to build mobile applications. So my career, at least for the last 10 years, has been spotted with like different ways to build mobile applications using JavaScript or using non-traditional languages. And that's kind of the place that I come from. And I've now kind of transitioned into Oculus. And guess what? We actually build Oculus applications using React Native or a variant of React Native. So that's why I'm kind of excited about this technology. And I'm excited to talk about this to you folks. Now, this workshop is not going to be about coding. This workshop is not going to be telling you, hey, this is how you should go do things. I thought I should take this chance to meet all of you wonderful people and talk a little bit about why we are building React Native or what the philosophy is. I'm sure the people at ACM Hack have done an amazing job teaching you how to build it. So the goal here is not to cover the how, but more of the why. Why is this important? Why do we build it the way we build it? And more importantly, what goes on under the hood of React Native? Now, the reason why that's interesting is because as you build apps, once you understand these basic underlying principles, you would be able to make that connection and you could go, oh, this is why I use this mechanism, or this is why I import Firebase, for example. So that's the part that I wanted to talk about today. But as I said, my history did not start with mobile applications. It actually started with web applications. In fact, when I was at Microsoft back in the day when Internet Explorer was the big dominant browser, I was actually a program manager in that group, primarily working on like W3C standards. I don't know how many of you have heard about W3C. And honestly, if this was a live audience, I would have just said, I would have just asked you and you would have raised your hands. But here, given that it is Zoom, it is hard. However, you do have reactions. So I will be asking you questions along the way. If you think you can use the reactions, I have it on my side here and I should be able to look at it. So how many of you have heard or know of what W3C is? I'm going to wait a minute. Let's see. Give me a thumbs up if you've heard of this or if you know what it is. Okay, there's like one person who's given me a thumbs up or two people who've kind of given me thumbs up. Okay, how many of you know how many of you know HTML, CSS? Let's see if that works out and if that can get some responses. Okay, that's good. So W3C is a working group that kind of defines how the HTML language exists. Like it's something that defines what the web should look like, and it's a standard that different browsers like Firefox, Chrome, Internet Explorer, Safari adopt. So I was a part of the group where I was doing a ton of web development, trying to define those standards. And a lot of the work that I did was started with web development. So I thought I should take you through this journey, which kind of spans almost half of my career, where I started from the web and came all the way to virtual reality. Along the way, I want to show you how the technology evolved and you can understand what goes through. So that's going to be the crux of my presentation. Also, given that I spoke to Eugene and he also told me that a few of you may be interested in also hearing about what is it to like getting into the tech industry in terms of like getting into Facebook or getting into one of the companies that kind of are at the cutting edge of technology. So I do want to talk a little bit about, spend some time talking a little bit about that part. I do not have slides prepared for that. I spoke to my HR people and recruiting people, and they said it's okay if I can just talk about it. So if people have questions about, hey, what does it mean to like interview at Facebook or talk about a career in technology, I'd be more than happy to talk about that towards the end. But the crux of this presentation is going to be why are we building React Native and why is it that the way you use React Native is the way you use it. So as I said, let's start from the beginning. And when I say beginning, I'm not talking about the Big Bang. I'm talking about let's start from the dawn of the website. So a long time ago, in a galaxy far, far away, there was this concept of a website. Effectively, if you look at a website, it's just blocks of components. So this is typically how a website would look like, where you might have an image on the right and you might have some text and stuff on the left, right? Like that's how you would typically write HTML and CSS. Before I continue, how many of you have written any sort of HTML? Can you give me a thumbs up if you have written any sort of HTML, CSS, or any web page or web related stuff? Okay, so that's actually a fair number of people. So I'm assuming that most of you know web programming. So with that, if you think about it, the way you write HTML, CSS is, this is how it displays it on the page. But when you try to write about it or think about it conceptually, the building blocks of HTML and CSS is more around a tree structure. You have to slowly, like the Jenga, remove blocks that you don't care about, slowly insert blocks so that the whole thing doesn't tumble. It is kind of fault tolerant in the sense that you can do whatever you want and it kind of works. But at the end of the day, the way you would think about it is a tree of components. It's basically one root HTML tag and then maybe a body tag and then one tag inside the other. So it's basically a tree. In fact, if you want to make your website interactive, all you would do is go and play around with trimming the trees. That's pretty much the job of someone who is a web developer, going and playing around with these trees, gardening these trees and ensuring that they form the right structure. So let's start with a simple tree. This is what an HTML would look like. Like if you remove the render function at the top, your HTML would basically be a div, and inside that div, there's a span and an image. So that's how this tree would look like. All that React does is it takes this structure and converts it into a code. So this is not JavaScript, right? Like what I'm doing here, or the blasphemy that React created, was you could add HTML inside JavaScript. Now, I'm not sure how many of you were around the time when React introduced this concept, but back in 2013, when React introduced this concept, the tech industry was all like, what the hell is wrong with Facebook? People were like, hey, this makes absolutely no sense. The conventional wisdom was that you separate your concern. So you separate your JavaScript and your HTML into different files. And that's how people used to work. And then suddenly this new framework comes at JSConf. And Pete Hunt and Tom Okino introduced this idea of, hey, by the way, you can also put HTML inside your JavaScript. Of course, this will not work on the browser. And that is why you need a compiler or a transpiler, something that translates this into more of a Java function, JavaScript function. So it basically takes this and calls what is called a create component. Now I wanted to put that code, but as I said, I wanted to keep it light on code. So I'm just going to talk about it. All you need to know is that this HTML structure inside the render function doesn't run as it is in your browser or on your mobile application for that matter. It is transpiled or it is converted into JavaScript functions, and those JavaScript functions called react.create component are what eventually give you this tree. Now, once you have created this tree structure is what is eventually projected on top of your website. And here I have an amazing product that I want to sell to someone, and I have like created like images and created this tree, and that's how it works. But again, a website is not a website if it isn't interactive, right? Like this is not a website from the 1980s. So if you want to make it interactive, what you would typically do is you would add maybe an input box where someone can type. And this is where the tree manipulation comes into play. And the way it works is you have an input text box. I just added a third node or a third component inside my component tree, and that manipulates my component tree. And because React manipulates it, it can go and get added to the website. Let me go a little bit deeper into this. But before I continue, any questions so far? Eugene has kindly accepted to moderate this. So if you have any questions, please type it in chat and Eugene can convey that to me. I don't have the chat open because though I have 3 monitors, I've kind of like taken up space everywhere. I don't have any more space remaining. So Eugene, please do speak up if there is any questions. But I'm guessing that this is the basic structure. Now what happens is, if you want to work with this, or if you want to like change this or respond to the input, this is the syntax that you typically use. Now I can show you the syntax, and I'm sure most of you are thinking, am I like a dinosaur? Am I living in the Jurassic era? What kind of syntax is this? What is this set state? Well, yes, I mean, when I started learning React, this is how we used to change state. That was not taught you in this course because what you are experiencing is you're not going through the pain of how it was in the good old days. You're actually experiencing the modern day syntax. You're not with the dinosaurs, you're actually kind of living on the edge. And today, the way you would use it is this. You would use a set state, and then you would go ahead and use that here. So this is the syntax that you're probably learning, that you've probably learned. I'm actually kind of jealous of you guys because you didn't have to go through the pain of using class components and stuff. So be happy that you're looking at functional components. This is so much more logically like better than what used to be. Anyway, so what happens is this is how you would typically write, hey, if my text changes, call the set text function. And then the value that needs to be displayed in the input box is whatever the value of that text is. Or in other words, if you start interacting with this, let's look at how it looks like. But before, we're not talking about a website, right? Like this is not a course on building a website, right? It's a course about building a mobile phone. So let's actually talk about it in terms of building it on a mobile device. Now, what happens is the mobile world is very, very similar to the web world in the sense that you can actually run a website in your mobile phone. Back in the day when I got my first phone, you actually didn't have a web browser. You had to write it in a completely different language. Now, most of you have an iPhone, or most of the phones that you have seen these days can render a web page in a much smaller size. Right? So let's start with that. So what happens is, let's say you as a user type in something in the input box. The browser sends a signal that calls the onChange function. The onChange function then sets the text and changes the value of the text. And this text eventually gets rendered. So this is your cycle that happens. And this is what React does to enable interactivity. So one of the things you should notice here is that you're not telling React what the steps are. So you know how if you have ever learned computer science, you may have learned like object-oriented programming, you may have learned like procedural programming or functional programming. This is more functional or more declarative kind of way. So what you do here is instead of telling the browser what are the 10 steps, what you end up saying is, hey, this is how I declare my UI to be. And React converts that declarative paradigm into something that's imperative. And these days, a lot of other technologies, including Swift UI or Jetpack Compose on Android, have embraced a declarative way of writing UI, and that's probably React's biggest contribution to the UI industry. Like anyone who's writing UI these days is actually thinking about it declaratively. So you're able to declare what your UI looks like, and here you have declared that my UI should have an input box. The value of the input box should be a text, and this is what happens when the text changes. Now, I would be cheating if I just told you, hey, this is what a mobile application looks like, because none of us like opening web pages on our mobile phones. Pretty much everyone wants to have an app. So let's actually talk about an app. So surprisingly, React.js, which is a framework to build web applications, is not very different from React Native, which is an app to build mobile applications. So the logic actually still remains the same with slight differences. So if you've heard about like web frameworks, React.js is that web framework. On the other hand, React Native is a way to build native mobile applications. So I'm going to talk about how this code snippet is going to change if it's React Native. The change is actually not large. It's just this. It's exactly the same except one difference. So let's see if you can spot the difference. The difference basically is this. So instead of using an input element, which is a native element that the browser exposes, which is something that like the browser gives you as a part of HTML, the mobile browsers don't understand HTML, right? Like mobile applications do not know what HTML is. So instead of using input, we just have a component called text input. The tree and components are exactly the same. In fact, the value and on change are exactly the same. And the way it works is also very, very similar. So this is how it works in a mobile application context. Except your mobile app doesn't understand JavaScript, right? Like if you have ever written a native mobile application, it runs using either Swift or Objective-C or Java or Kotlin or something, right? It doesn't understand JavaScript. So how does this really work? In reality, if this was an Android application, these are two separate worlds. The world of Android and something, or world of iOS and Android, and something that should ensure that, hey, all the JavaScript stuff that you talk about, you can actually go and transfer it over. What you really need is a bridge that bridges these two worlds together. This bridge is the main source of communication. It's playing the game of telephone, basically. It's saying, hey, these are messages from Android, send it to JavaScript, and the reverse. So you can't just call methods from one to the other. What you do is you basically, instead of the set value, you serialize that, and you create like all these messages in a JSON format, serialize it, and send it over. So that's what the bridge does. There's also one more thing that I kind of lied about. You know, whenever we talk about writing websites, we talk about HTML, JavaScript, but we also talk about CSS, right? What about CSS here? We didn't talk about that. How is the layouting happening? We all know that CSS is used for specifying how should the web page look like. And mobile applications don't understand CSS, just like they don't understand JavaScript. So how does that work? So what React Native does is React Native has its own way of parsing that CSS. In fact, on the browser, you have a CSS parsing engine. You have something that looks at the CSS files, understands it, and then lays it out. On React Native, we have our own CSS parser. What it does is it basically creates this tree, tries to understand what is the CSS for each of these elements, and then does that intricate layout dance and sends it over to the mobile browser. Effectively, this is how React Native works. So this is the typical workflow of React Native. So just to recap, as soon as the React Native application is rendered, a message is sent from the Android world to the JavaScript world saying, hey, the mobile app is ready. Tell me what I should display. The JavaScript will run all of your business logic. In this case, it will say, hey, there's an input the element that needs to be displayed. So it will say, okay, display an input element to me. But then what does display mean? Because the display here is CSS, right? So it will send it to the CSS engine. The CSS engine will try to figure out what it is and then lay it out on the browser. So this is the kind of workflow or what happens under the hood when you write all of your React Native code. Before I continue, any questions? I want to take a pause here. I wanted to ensure that people kind of understood this. Give me a thumbs up if this all made sense.
And there haven't been any questions in the chat yet.
Awesome. Looks like there are still a few people who haven't given me thumbs up. Are there any questions? I want to ensure that like you kind of understand that. Are there people who haven't given me a thumbs up? Like, do you have questions? Am I going too fast? If you can give me like immediate feedback, I can like ensure that you folks are following along. Any questions? I'll wait for a minute before I continue. Okay.
A little.
Yeah.
I have a question. Could you talk a little bit more about like what layout means?
Sure. So layout basically means laying out elements on your page. So it essentially means, hey, this should be at X. So think of your screen as an XY grid. On your web browser, you would say something like margin 10 pixel, padding 10 pixel. Or you would say position absolute, this should be the X value and this should be the Y value, right? That's basically what CSS layout does. On the mobile browser, you have a similar story, except you need to figure out a way to tell your mobile phone how do you do it. If you're writing a pure Android application or if you're writing a pure iOS application, there are these concepts where it's called auto layout, where you say, hey, these are the constraints for my layout, lay it out like this, right? Because we are writing React Native and because we kind of like all of us kind of know HTML and CSS, a CSS-based layout system makes our lives much, much easier. So what React Native does is it lets you write CSS for all of these things. You know, if you have you folks written stylesheet.create and then added CSS? How many of you have done that? Is that something that was taught? Awesome. So you know when you have written all of those stylesheet.create, you're basically setting the CSS, right? So what it happens is those functions are parsed by JavaScript. They try to understand, okay, this is where I should lay out my button and I should give it so much margin and so much padding. That's what the layout engine does. Does that make sense?
Yeah, thank you.
Awesome. Any other questions? Okay. So the next thing I want to talk about a little bit is we just saw how React Native works in terms of like what is the workflow. Now I want to take a step back and talk about what is in React Native, like how's the kind of code organized, how is like what are the different components inside React Native itself. So it's the mythical block diagram that you would draw for any system design. If you have taken any system design classes, or if you have like, and this is not specific to computer science, any kind of engineering you've taken, people kind of like to draw block diagrams. This is my attempt at drawing a block diagram for React Native. So there's this entire React Native code base. And the best way to think about it is, in case of React Native, you want to draw stuff, right? Like that's the whole point. You want to display user interfaces. You want to display like a button, for example, right? So what React Native does is React Native doesn't go and draw its own button. React Native actually uses the UI components that are native to the platform. What I mean by that is a React Native button is no different than an iOS button. And the reason why this is important is because when you scroll a React Native app, the scrolling, the acceleration of the scroll, the feeling, the smoothness of the feel is exactly like what it would be if you were to scroll on an iOS application. In more technical terms, what it means is that the curve of the animation, the Bezier curve that the animation follows, is the exact same in iOS and React Native, because React Native pretty much uses the iOS components. So in this case, a button is an iOS button or an Android button. So you have this idea of a view manager. A view is anything that's visual, that's displayed on your screen, like a button, a checkbox, text, tons of text, images, all of those. So there's a view manager for every type of display. So for a button, there's a view manager. There's a view manager for images. There's a view manager for text, etc. So React Native has these things called view managers. And these are the ones responsible for connecting your JavaScript code or your React Native application and making it look like a real iOS application. So this is that glue layer. There's also a concept of native modules. So just like view managers has to do with everything that's visual, native module is to do with everything that's not visual, that's an API. Example of these include like camera, geolocation, accessing your files, all kind of like hardware gizmos on your computer, Bluetooth, Wi-Fi, etc. So all those kinds that are not visual but that are APIs are accessed via a native module. So just to recap, there are two concepts here: a view manager, which is a way to bridge the gap between your React Native application and anything that's visual on the phone, and a native module, which is like anything that's non-visual on your phone, like camera, that is like native to your phone. So it's camera, Bluetooth, Wi-Fi, etc. So these are the two main parts or two main components of React Native. In fact, if you have integrated Firebase, if you remember, you import Firebase, right? So what does that really mean? What it means is that Firebase is a native module. And that native module, that native Firebase module connects to the Wi-Fi system and ensures that you're able to the networking stack and ensures that you're able to make networking requests. Can people give me examples of what are view managers? Like, what are some of the common view managers that you may have used in this class? Like, do you import anything externally, like maybe a vector icon, maybe a dialog, a button? Do you folks have done anything? Have you done anything like that?
Yeah, we've done vector icons.
Okay, so vector icon is a very good example. That is a view manager. And as I said, both of these are the ones that bridge React Native, which is primarily written in which contains like all this bridging between Java and Objective-C. All of this is written in Java and Objective-C because it interacts with your native system. But hey, your code, you don't write Java code or you don't write Objective-C code, right? You actually write JavaScript, right? So how does that work? So what we also have is what is called a JavaScript virtual machine or a JavaScript engine. The best way to think about it is that this JavaScript engine takes all of your JavaScript and interprets it and sends that interpreted instructions over to React Native. I'm guessing all of you know what an interpreter is. An interpreter basically takes your language, like a Python has an interpreter, for example, right? So an interpreter takes your language, understands it, breaks it down into instructions, and then sends that instructions to the system to execute. So that's what a JavaScript virtual machine does. It reads your JavaScript, parses it, tries to understand what it is, what the instructions are, and sends it down to React Native. The JavaScript virtual machine or the JavaScript engine that we use is called JSC. It's or JavaScript core. This is the same interpreter that is bundled with Safari. That's what exists in the open right now. But Facebook also wanted to make this much, much faster because that's where most people write their code. So Facebook came up with a JavaScript virtual machine called Hermes. Hermes is a bytecode JavaScript virtual machine that lets you run JavaScript much, much faster than JavaScript core. It has a super quick startup time. It's only for mobile applications where like memory is constrained. So it's like kind of a bespoke React Native specific JavaScript virtual machine. So that's what you have. And then on top of this, you obviously are writing React code. So you have the React JS library that is responsible for doing all the state, the virtual DOM, all of that. And on top of React JS, you have product code. So this is the place where you are writing code. So under the code that you write, there's all of these things that are going on. Of course, as I said, there are multiple view managers because you have multiple components. There's also multiple native modules because you're probably accessing camera and Wi-Fi and networking, etc. Right? So this is typically what the structure looks like. Also, React Native lets you be extensible. What that means is that React Native can let you also import modules from the outside. Vector icons, Firebase, all of those are examples of view managers and native modules that you get from the outside. Whoops, I think I went back. Give me a minute. In fact, what we are trying to do is we are trying to encourage the community to come up with a core set of well-defined, well-structured, well-tested native modules so that the core of React Native itself is super thin and there is a good community around React Native, a good open source community around React Native. Facebook believes in open source, and I think the open source community kind of keeps the React Native ecosystem going. There are tons of people out there, many of them students who write view managers and native modules. Like the Firebase one that you use is actually an open source native module written by an independent person. Vector icons is also maintained by someone who's just working on it in open source. And we kind of support them, help them. They talk to us. And we kind of encourage open source, and we try to ensure that there are many view managers and native modules out there for people to use. So that's pretty much about the technical aspects of React Native. Before I jump into hey, why React Native? Do people have questions? Also, a quick time check. It's 6:34. I'll probably go on for another 5-10 minutes before we take questions overall. I hope everyone is okay with that time. But do people have any questions so far?
Yeah, so we have one question. Could you elaborate a bit more on how the extra time taken by the JavaScript interpretation and the native conversion?
So what happens really is there is no real native conversion because as I told you, like if it was JSC, yes, there was extra time taken where every command or everything that executed on JavaScript got converted into what the native understands. That's not the most efficient way of usage, or like performance is bad, right? And that's the whole reason why we created Hermes. So what Hermes does is, instead of shipping JavaScript with your application, I mean, why do it when the app is running when you could actually compile it over, right? So that's what Hermes does. What Hermes does is, instead of sending your JavaScript, it compiles your JavaScript into bytecode, similar to how C is compiled into, like, C code is compiled into like instructions, right? So just like that, JavaScript is compiled into Hermes bytecode, and that's what gets interpreted. So that's the best way to avoid performance, because you're basically running it at the machine instruction level, right? You're saying, hey, these are the bytecodes. Bytecodes are extremely efficient. Run it as fast as you can. And Java, like the JVM, the Java virtual machine, where you write Java language, that gets converted to the JVM bytecode. Hermes is exactly the same. And that's why I think this whole concept of virtual machine is very, very important.
I actually had a personal add-on question to that, because I've heard that one of the biggest trade-offs between using a cross-platform framework like React Native and just native development is the overhead that comes from the translation time. So when you have something like Hermes, when it gets converted into bytecode first, how did the performance metrics sort of weigh against each other after that change to bytecode?
So the reason why we did this is because performance is very, very critical for an app as big as Facebook, which has around like 4,000 engineers working on it. This is the reason why we even created Hermes. Once Hermes was in a lot of cases, it was negligible. Sometimes Hermes was actually faster. And the reason why Hermes was faster was because you don't have to get the entire bytecode in memory. What you can do with Hermes is you can mmap bytecode into memory blocks. So you read a chunk of file, mmap it directly, and that becomes machine instruction. So it's much, much easier. There's no simple copy pasting and stuff, which kind of speeds up the execution. So, and that's the reason why we wrote Hermes. To your question about what about the performance in general, right now we have gotten it to a state where it's almost negligible. Like, your bottleneck is not going to be running JavaScript. Your bottleneck is probably going to be other things like networking and stuff. Also, if you're interested in React Native performance, I can link to a talk that I gave at ReactConf previously that kind of talks about like the way we measure performance, what are some of the things that we do about performance, and what are the performance trade-offs. That actually is a good place to get started on React Native performance and understanding and comparing and contrasting it with what native performance is.
Yeah, sure. You can actually send me an email about that and I can share it with the rest of the people. Okay, so there are a couple more questions. Is the anticipated core module system listed out in some standard documentation, like the W3 standards?
It's not a standard, but it's in a GitHub repo. I mean, gone are the days when people read documents. Come on, how many of you have ever read documentation? Tell me. Like, raise your hand if you have read documentation, really. I'm guilty of that. I have not. So it's not in documentation. It is actually in a GitHub repository. The GitHub repository it's a GitHub organization called React-community. And all the core modules are in the React community, where like there's a core set of contributors who are maintaining it. The only difference between core and non-core is that we ensure that core modules are up to the standard, and you can just pick up and without thinking use it. The problem with open source is, like, if you have written Python or if you've written like anything that has any open source component, you will eventually run into a case where you're like, hey, is this trustworthy? There are like 3 or 4 implementations, right? And you'll not be sure which one to pick. Like even React navigation system, there are 4 navigation implementations. You don't know which one to pick. The point of React community is to ensure that, okay, you don't have to think about that. If you're a business, if you're a startup, for example, you don't want to spend your time thinking about which native module or core module you want to pick up. And that's why we have this core community where you can just pick up trustworthy modules and use it.
Okay. Speaking of React navigation, our last question for now, this is related to the block diagram you showed before. Where would React navigation fit in that block diagram?
So React navigation, believe it or not, is actually a view manager. And the reason I say that is, if you think about, if you have ever used React navigation, there's a concept of screens, right? And a screen is a view. So all that React navigation does is it lets you change screens. Like, yes, it has a fancy way of changing it, but boiling it down, it lets you change screens. And those screens are big components inside which you can display your own smaller components. So React navigation is actually a bunch of view managers. Any other questions?
That is it for now.
Awesome. So let me talk about why React Native. Like, why? I think performance was a very good question that you asked us. So I should probably answer the question of why is Facebook so much invested into React Native? Like, where are we using it? You would actually be surprised, but there are more than more than 1,000 entry points. I think entry points is actually a convoluted term, but there are tons of apps, both internal and external, that use React Native. I would even say that pretty much all of our internal apps use React Native because it's so much easier to write. But even in external apps where it's customer facing and where we want to ensure that people are having that smooth user experience, we use React Native with this thing called the ads manager. So this is the place, like most of Facebook's revenue comes in on in ads, right? So we use React Native in ads manager. We also use React Native in analytics. These are like, both these, if you see, are like very heavy on graphics. The amount of data that they crunch is extremely high. They have tons of graphs, and you have to like be able to like interact with them smoothly. So all of these places are places where React Native is actually used. The Oculus companion app is completely written in React Native. It uses Bluetooth to connect your headset. It lets you install games on your headset, play around with that. All of that is React Native. Instagram also has parts of React Native in it. In fact, the main Facebook app has tons of React Native screens. So it's not that we have one app that's React Native and the other is not. Even in a single app like Facebook, a lot of parts of this app are React Native. Marketplace is React Native, dating is React Native, your profile is React Native. So there are a bunch of places that are actually React Native. And if you move through the app, you actually wouldn't even notice the difference. And I think that kind of speaks to the negligible performance difference between both of these and the amount of work that our teams have been doing around performance. I see a question around Flutter. So the question here is, Flutter has been becoming more and more popular in the past few years. What are some of the benefits and the disadvantages of React Native? What do you think is the future of mobile app development? So I'm personally a big fan of Flutter. In fact, we had the Flutter team come out to our offices. We went to the Google offices to talk to the Flutter team. Flutter is an excellent framework. I don't know how many of you have heard about Flutter. Maybe this is too much to go into depth about Flutter, but there's one thing I do want to talk about. As I said, I'm personally interested in like non-traditional mobile app frameworks, and that's what led me to go into Flutter. In fact, I even wrote a way to convert React Native modules into Flutter modules so that you can use them in Flutter. But the point of Flutter is this: React Native lets you use your native UI buttons. React Native lets you use your native UI components. Flutter, on the other hand, uses or draws this completely from the scratch. So if it's a button, it actually draws the lines and stuff. And Flutter's philosophy is that if they're able to access the entire drawing API, and they'll not be limited by what the operating system gives them. So they have this engine called Skia, S-K-I-A. They have this engine called Skia. That's the same rendering engine used in Chrome. So what they do is they pick up the Skia engine and they use that to draw everything. In fact, a fun fact is when the Flutter team came to us, we asked them, hey, if you're going to be doing all of this from scratch, how do you ensure that your animation curves and your buttons and everything look exactly the same? Like animating it is hard, right? So we asked them, how do they do it? So the funny anecdote there is what they told us is they have high-speed cameras in their office that records a scroll and tries to reconstruct the curve based on that recording. And what they found is that the curve that they had reconstructed was actually a lot more efficient than the actual Android curve, so much so that they actually went and told the Android team to change their curve to use their equation. So Flutter, those guys are amazing engineers. Like they do really great stuff. And the biggest challenge or the biggest difference is that they do not use native UI components. So let's say a new version of iOS comes out tomorrow. Flutter works to ensure that their look and feel matches what iOS does. That's the big difference. To your question about what is the future of mobile application development, I have no idea. Every single prediction I've made so far has been wrong. Like I first started with web development. No one cares about the web now. Then I went into PhoneGap or Cordova. No one cares about it now. I'm not saying that people are not going to care about React Native. I think the reality is this. No, when I say no one cares about it, that's incorrect, because PhoneGap today has approximately 24% of mobile applications that are built using PhoneGap, though it's not the most modern. This is more about what people want and what are people comfortable with. Like Flutter, for example, is written using Dart, while React Native is JavaScript. So that there's one distinction right away. Are you going to learn a new language or would you rather prefer JavaScript? Would you prefer to like wait on? So they have a bunch of other constructs. They also can run on like different platforms, like React Native can only run on desktop and mobile. They can run on like IoT and stuff. So there are a bunch of different considerations. A lot of for some weird reason, front-end engineering or UI engineering has this likeness for adding drama, and they try to like pit one against the other. Like back in the day, it was React versus Angular or jQuery versus YUI. People like to pit React Native versus Flutter. But what I would say is that as an engineer, I'm kind of curious and I like to read both and like to understand what both do and learn from each other. So to your question about what is the difference of who's going to be the future, I do not want to take bets. I'm pretty bad at gambling. ReactConf happens in Las Vegas, and every time I go to Las Vegas, I have not gone to the strip because I'm bad at gambling. So no, I'm not going to tell you that answer. The question is, many just compare performance, number of users, but never about the actual difference. Yes, that is true. Comparing users is not going to help because it's more about what you want than what the users are. The next question is, what about React and WASM? Or WASM is WebAssembly. So for those people who don't know how are we doing on time, Eugene? We have only 15 minutes left.
Oh, we're actually good for 6 to 8.
Okay.
Yeah.
So
you're perfect on time.
Your question is, what about React and WebAssembly? How many of you here know what WebAssembly is? Raise your hand if you know what WebAssembly is. Give me a thumbs up on the. Okay, do you want me to raise your hand if you want me to explain what WebAssembly is? Okay, so the concept of WebAssembly is this. You know how we've been saying that JavaScript is interpreted, and hence it's slow. What WebAssembly does is it kind of does what Hermes does, which is like send over bytecode. So you can kind of compile. It's a compiler destination. So you can you write it in different languages, like say Rust or JavaScript, compile it to machine bytecode, and your browser can run that. And because it's bytecode, it's much, much faster. The concept is very, very similar to what Hermes is. Now to your question about, are there any interesting things happening between React and WebAssembly? Yes, there are. We are thinking about converting. So here's the thing, right? Like most people like to write JavaScript. So that's good. But is there a reason why React core itself needs to be in JavaScript? No, right? Like why should the React core be in JavaScript? Why can't it be WebAssembly? So there are people who have internally tried out this idea of, hey, maybe we just compile React core into WebAssembly because that doesn't change as often. And then the developer code still can be in JavaScript because that's fast. WebAssembly is still pretty early. The speed of interaction between JavaScript and WebAssembly is not great. It's getting better. But I think I can see a future where WASM could be the place where like frameworks are written in WASM, and you as an individual, if you don't want to learn Rust or if you don't want to have like complex tool chains, you can go write JavaScript. Again, remember the appeal of JavaScript is you open a browser and you're ready. You don't have to set up complex tool chains, right? So WebAssembly is not like WebAssembly, Python, all of these languages have some setup. Most computers come with a web browser. So there is still an appeal to JavaScript. And I think that's why I do foresee a world where a lot of the core frameworky stuff would be written in WASM, while JavaScript will be still something that's useful for the user line. Okay, so coming back to this, to my slides, I spoke about Facebook, where Facebook Marketplace, dating, profile, Instagram, Oculus, Ads Manager, WhatsApp, all of these guys use React Native. But that's not the only place where React Native is used. Microsoft is heavily invested in React Native. Microsoft Skype actually has it built in React Native. The Skype desktop and Facebook Messenger desktop are built in React Native. If you have Office, the Office applications, so Outlook, Word, and stuff, those have parts of React Native in them. In fact, Microsoft is one of our biggest partners in React Native. The Alexa app is written in React Native. Amazon is also a big partner using tons of React Native. Tesla app, as far as I know, is written in React Native. There are a bunch of big people, but yeah, Microsoft has a ton of things that are written in React Native. Here are some of the other companies. One thing I want to call out is people often ask me, hey, are games written with React Native? The answer is yes. I don't know if you've played on Words with Friends. It's a game by Zynga. That game with rich animations is actually a React Native application. They came over to our office to show us and work with us on some of the performance issues and stuff. But yes, you can write games in React Native if you want to. It makes the iteration speed much faster. It's not really a 3D game, and it makes sense. So for a 2D surface, it makes like absolute sense to write in React Native. In fact, here's like a bunch of apps that I came up with that are all written in React Native. That brings me to the end of my presentation. I'm super excited about the future of React Native, and I'm happy about like where people have been able to take React Native. I am definitely curious to see what you, the superheroes of React Native, doing the next generation of React Native apps are writing. So please do let me know. This is my Twitter handle. Follow me, ping me here. I'm usually active. If you have questions, just let me know. That's pretty much all I had in terms of my presentation.
Awesome. Thank you so much, Ram.
Yes.
Cool. So we can go ahead and get started with the Q&A session. So if you have any questions, Ram, I think you can see the chat now, but I'm also free to moderate for you if you want that too. But yeah, so these can be questions about Ram's presentation, anything about React Native or mobile development in general, or just things about Facebook that you're interested in. In the meantime, I had a question. So I don't know if you're allowed to say this, but what is the current split of mobile development frameworks being used at Facebook?
I think I can't say that. Mobile development frameworks. Okay, let's see. There's at least 4 popular frameworks. And inside Facebook app itself, there are 4 popular frameworks. And then there's a bunch of it's hard to define what a framework really is. Like, where does the broader of like a library / a framework come, right? But I think inside Facebook, we have Litho. Litho is a way to write declarative UI, but in Java. So we have that. We have a way to do server-side rendering. We have React Native, and we have one more. So approximately 4-ish frameworks in. So there's Component Kit / Litho, React Native, a server-side rendered framework, and one more. The question is, are there difficulties in integrating these kind of frameworks? It's actually not. At the end of the day, and this is one of the other things about Flutter versus us, right? Like, the reason why we didn't go the Flutter route is because we wanted to integrate. Like Facebook app, you cannot stop development and say, hey, all of us have to now go use one framework. At Facebook, management doesn't make decisions. It's mostly like at an engineer level who say, hey, this makes sense for us, so this is what we're going to use. So asking people to stop doing what they're doing and then convert over from one to the other doesn't make sense. And that's why it is important that all of these frameworks integrate. And when I say integrate, I'm talking about like from Marketplace, for example, or from your newsfeed, you can actually go to Marketplace. So newsfeed is written in one framework. You click on something and you go to Marketplace, which is React Native. So we actually have to deal with these issues where as soon as you click on something that takes you to Marketplace, we start up React Native in the background, or we actually use ML to try to figure out if someone will go to Marketplace and start up React Native in the background. And then by the time they go to React Native, by the time they go to a React Native page, React Native is already started and some of the views are already rendered. And that's why like you don't even see a performance difference. It's as if it's a seamless transition over. There's a question on how closely is Facebook involved in moderating and contributing to the React Native open source community you mentioned earlier. So let me be honest. The reason I got into Facebook was because of my work at open source. Like I was at Microsoft. I was looking at what other frameworks should Microsoft use. React Native was a new kid in the block. I did a bunch of open source contributions, and then met the Facebook people at ReactConf, where I was speaking about some of my open source libraries, and I got into it. So Facebook is extremely involved in open source. We believe that open source is the way in which like all of us grow together. And we are committed to not just helping the people who are doing open source, like we run like ReactConf, and back in the day when human beings could actually be within 6 feet of each other, we used to run things like conferences. We also do like React Wednesdays where people get together, or people used to get together to like talk about frameworks and stuff. So we are actually pretty heavily involved in the open source community. Like, yeah, as I said, like I got my job primarily because I was doing all of this open source work, and then got in touch with Facebook, and then I figured, hey, it just makes sense for me to come over and do React Native at Facebook. The question is, any difficulties when dealing with iOS and Android specific problems in React Native? I wouldn't say it's difficulties in React Native itself as much as the platform. Like, for example, even if you're writing an app that's just pure Android and pure iOS, you will encounter the differences. So it's not necessarily difficulties as opposed to differences. And the way we look at it is, someone who has an iOS phone has only an iOS phone, and they only think about iOS way of doing things. On the other hand, someone who has an Android phone has a different way of thinking. So we need to ensure that we cater to both these audiences, and hence bake in those differences into our application. So there could be a chance where in case of React Native, you might have to have an if else where you say, hey, if the platform is iOS, do this, show this kind of a UI, or if the platform is Android, show this kind of UI. In fact, React Native even has a way to say component.ios.js and component.android.js will be picked based on what component you're running on, if the difference is that wide. That's how we typically deal with different like platform specific differences and problems.
I actually had a question about Expo. I know our hack workshops, we introduce React Native with Expo, but I was wondering, in context with your like diagram, how the flow works, is there any differences between just React Native and then React Native with Expo?
So think of Expo as like, so React Native is pretty much DIY, right? Like you have to do everything by yourself, add your own native modules, add your own view managers and stuff. Expo actually brings all of that together in a very good format. In fact, Expo is a great partner for us and a big contributor to these core module community. In fact, a lot of the Expo modules are in the core modules. So in case of Expo, you get a lot of things for free where setup is not a problem at all. Expo is amazing at getting started because you have vector icons, you have like all the native modules that you need it always there. So you don't have to worry about like the quirks of platforms and stuff. So they've taken care of all of that for you. So the biggest, what I would say is like React Native is the basis on which Expo is a wrapper, and Expo, the Expo wrapper kind of like gives you all these niceties, which otherwise you may have to pick and choose. Now, when would you use Expo and when would you use React Native? That will completely depend on you. Do you want to, so the question is, do you want to start off with something that's minimalist and then build on top of it? Or do you want to start off with something that's like a pre-packaged thing and then build on top? That's the big difference. Okay, the question is, I wonder why React Native doesn't have its own emulator and only renders using Android Studio or Xcode, which has a decent load time before utilizing hot reloading. So this is actually a good question. We tried to build a React Native emulator. In fact, if you've been using Expo, you can technically use their emulator, which is a web-based emulator. Like React Native, the Expo Web is that emulator. The reason why we usually don't suggest that is because the moment you go into building your own emulator, you're emulating things. You're not close to what the reality is. So we, at least at Facebook, we do believe that we want to embrace the platform and ensure that we give the capabilities of the platform to our user. Now, when you're starting off, it might be okay for you to run that emulator, and that's probably why you should be running the Expo emulator. So if you run, there's like a React Native playground where it basically is a web container and it runs Expo Web and runs HTML and CSS. So to your question about, hey, why doesn't React Native have an emulator? It does. Expo Web is that emulator. So the question is, in your workshops, you do Expo emulator, but it does look very different on the iPhone and the Android phone. So yes, that is correct. And this goes back to that philosophy question, right? Like if you had to do this on Flutter, your app will look exactly the same on iOS and Android. The question is, do we want it to look similar? And the approach that React Native adopted is we say, hey, it should not look the same on both iOS and Android because Android and iOS have design patterns. They have like a specific type of button, like this, the share sheet. There's like a share sheet from the bottom on iOS, while the tab bars are at the top and the sheet comes up from the top at Android, right? So we want to ensure that the user experience that we give is what people would typically expect. Is what typically people would expect. From a user's perspective, they don't care if it's a React Native app or not. So I think that's the reason why we believe that we would want to embrace the platform. You can continue to use Expo today and it will look exactly the same. Like if you were to completely go all the way into Expo, you have ways of saying, hey, I want to draw it on or draw it by myself and it will not look different. And that's perfectly fine too. Question is, any tips for a novice developer trying to master React Native? So mastering is an overloaded term. I don't know what a master does, to be honest, but if the question is more about, hey, how can I learn more about React Native? I think what I would suggest is React Native is open source. You now kind of have an idea of what React Native looks internally, right? Start going and poking around with your source code. if you know Android or if you know iOS, open up your Android Studio, start putting breakpoints in the React Native source code. That will actually walk you through how React Native works, and that will probably help you learn a lot more. And I'm going to be absolutely honest with you here. React Native has so many moving components. Like it has Hermes virtual machine, it has all of these different view managers, it has the React core. Even people on the React team don't know everything. There's no way you can know 100%. And I think honestly, as engineers at Facebook, one of the things we believe is it's not about knowing 100% of the things. It's about knowing how you can get a job done. So knowing where things exist and then going and understanding it when required, rather than just having a knowledge of 100% of the things. The next question is a question regarding React itself. There is some criticism that React applications are more data intensive due to the needing of loading largest JS packages, which is exclusive towards mobile only, data plan dependent users. Do you have any thoughts? That's a good question. What you have learned is kind of the basics of how you write React Native. And that's like the complete unoptimized, just easy to get started way. The reality is at Facebook, we have this method called download on demand, where let's say you are on marketplace, or let's say you are on dating. We will not download the JS bytecode. Again, we are not remember we are not downloading JavaScript as it is. You're downloading bundles, bytecode, right? We only download the bytecode for dating if you are going to go to dating. We will not download marketplace. So that way, it is not data intensive because you're only getting what you need. The funny thing is you can't do this with Android or iOS. With Android or iOS, you have to get the entire APK, right? And for companies like Facebook, for companies like Uber, Amazon, a lot of our users are also users who are on data plan in countries where data is actually expensive. So much so that we know of people who actually go to a shop, connect their phone via USB and transfer the APKs over or transfer the apps over because they don't want to waste money on downloading Facebook app. So we cater to audience like that. And for us, the APK size or the IPA size, APK is the Android app, IPA is the iOS app. So the Android app and the iOS app sizes are important. And React Native actually lets you download selectively based on what you use. Those are pretty much all the questions that I've seen. So yeah, those are pretty much all the questions that I see here. Anything else people want to know? Okay, the question is, I think node modules have been criticized a lot with too many chain dependencies. Yes, that is true. But here's the thing with React Native. Your node, you can have a ton of node modules, but remember that at the end of the day, it's a dependency tree, right? You can map down that tree. And let's say you have 10 screens. You can get to a world where you can actually say, hey, for this one screen, what are the different node modules I really, really need? And download on demand actually prunes that tree so that we only download absolutely the things that you need and nothing else. So yes, your dev machine is going to have a bunch of node modules. But at the end of the day, what gets downloaded on the user's device can be trimmed down to something as to only the JavaScript that's absolutely required, and also in the bytecode format, which is much, much smaller. Any other questions?
It doesn't seem like there's any more in the chat, but if you're okay on time, I also wanted to open the floor to some Facebook general questions.
Yep, let's do.
So you mentioned this a little bit earlier, but you actually found your job at Facebook through your contributions in open source. I kind of wanted to touch on that because that's, especially for us as UCLA students, it's a little bit more non-traditional, because for us, we feel like the only way to get it is through studying really hard for internship questions and going to the interview and then maybe bombing the first year and then trying again next year and all that stuff. So when it comes to all that, do you have any advice when it comes to interview prep or just finding a job at Facebook, even if it's not traditional?
So I think we are actually lucky to be in an industry where it's not just about, hey, like I give you an example. My wife is a doctor in UCLA, and she has to study. In fact, she's a doctor and she's still studying. So like in the medical field, you have to study, and the higher you go up, like if you have to become a dean and something, you have to continue studying, right? It's not like that for our case. For our case, there are multiple alternate paths. Going through your UCLA course, your campus recruitment, and like looking at getting into the interview is definitely one, but there are multiple other ways. Like Facebook heavily values people who contribute. Like all we care about is, hey, are you good? Can you write code? Can you write good code? And there are multiple ways to show that off. One is definitely through the interviews, through the interview process. But obviously, like let's say you've done your own side project and you're actually pretty active. That's actually a big way to show that you can run a big project. You can actually contribute to something that's already big. The other thing is contributing to projects that Facebook kind of owns. In that way, you'll come to know, talk to Facebook people, and they'll just refer you in. And that's a very easy path. The other way is speaking at conferences, for example, like do some work, talk about your work to people outside. So the TLDR basically is show companies that you can do the work. One way of which is through these interviews, campus interviews, but there are multiple other channels, and I wouldn't want to discount the impact that these other channels can have. Like I'll give you an example, right? Like what happened was last year when humans could meet each other, we had a bunch of folks from UCLA, from ACM actually come down, do a campus tour for us. And for the people from UCLA, it was more like, hey, they just wanted to see how Facebook works. But for us, it was a way for us to expose, hey, this is what Facebook is. If you're interested, come talk to us. And we did find a few really interesting people who were really promising, and we kind of like got them into the interview. And they were from non-traditional, non-computer science background. So it's just about like ensuring that you want to get there, and then how do you present yourself to saying, hey, I've done this work and hence I'm capable. And of course, interview is the most standard, most tried approach, and I wouldn't want to discount that either. Like a lot of prep does go into interviews. I want to respect that. That's definitely a well tried and tested method.
Cool. Any other questions?
I had a question about, you said your role at Facebook was engineering manager, and I was wondering how closely or how far removed you are from like an actual developer's role. As I understand, engineering manager is more big picture type of things, but I was wondering at Facebook, how does it work for you?
That's actually a pretty good question, and your assessment is right that in general, engineering managers are expected to look at the big picture of strategy stuff. But the reality is, you can't look at strategy if you're not grounded. So let me actually take a step back and tell you what is expected of an engineering manager. So Facebook is a very engineer-driven company, so much so that people, like there are tons of grassroots efforts, and people are self-driven. Like they want to go get things done. So as an engineering manager, your expectation is that you support your people. In fact, I never say I supervise the people who report to me. I always say I support them. And that's important. That though it's a small distinction in the word, it's kind of important because it's my job to ensure that I unblock them. And one of the ways I can unblock them is actually learning the tech and sitting with them and having those technical discussions. Another way I can unblock them is actually sitting down with them during deadlines and actually sitting and writing some code. So this will heavily vary between engineering manager to engineering manager. But whatever it takes for an EM to unblock the people they work with, they would be doing it. And it could mean that maybe I don't know that part of the code and I introduce them to someone else, some other EM who knows that. So to your question about how much am I into code, it's a very personal preference, and it is a very situation-based scenario where, like, if it's required, I will do it. In my personal case, I'm actually very deeply involved. In fact, I even sit down and write code today just because I enjoy it. Of course, I don't put myself into critical path because I know, at least personally, I know that with the pandemic, with a kid around, it's going to be impossible for me to be able to like sit down and finish a feature. So I try to remove myself from the critical path as much as I possible, and I mostly write code because I have fun writing.
All right. Any other questions? Okay. If not, I think we can end there. Thank you so much again, Ram, for doing all of this in your presentation and answering all of our questions so patiently. Yeah, I think that's all we have for everyone here. So thank you so much for sticking around and also asking your questions. yeah, this recording will be up on YouTube tomorrow, I think. But besides that, that's all we have planned. So thanks again.
Awesome. And you guys did speak about doing like a showcase. If there's an external write-up, do send it to me or to send it to us. I'm sure like Christian and I'll be delighted to take a look at the kind of like amazing projects that you folks have come up with.
Yeah, of course. We have a dev post submission, so I can give you the link for that as well.
Awesome.
All right.
Bye-bye.